Hello everyone, welcome to IB Math Solution. Today we will be studying about sets. It is in chapter 2. So what are sets? Sets are a collection of objects. Now what are these objects? These objects can be anything. Numbers, they can be alphabets, they can be vowels. And in general we call these objects as elements. So let's say if D is a set of digits, then we can write D as starting curly brackets 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is how we write a set in curly brackets, and these individually are called the elements of the set, and so on. Similarly, if C is a set of vowels, we can write C as A, E, I, O, U. So this is what we mean when we say C is a set of vowels. Now there are some notations in sets. These notations are, let's say, S is a set which has elements A, C, E, X, Y, Z. These are the elements in S, and S is a set. A is an element of S. Here we can say A is an element of S. And how we can write it in set notations is like this: A is an element of S. This is how we write the same statement in set notations. Now B is not an element of S. So B is not an element of S. So we cross it. And number of elements in S, how we write it is N parenthesis S. This is how we write number of elements in S. Now there is some more notation about it. So let's say there are 4 sets. S1 is 1, 2, 3, S2 is A, B, C, S3 is 1, 2, 3, 4, and S4 is 1, 2, 3. So we can say S1 is equal to S4 because they are equal. They have equal number of terms and these terms are equal. What are subsets? Subsets are those sets which are the part of a bigger set. So for example, if we take S1 here and S3 here, we know each element of S1 is present in S3. So when each element of S1 is present in S3, then we can say S1 is a subset of S3. Now each element of S1 is also present in S4, then we can also say, or S1 is also a subset of S4. Now what are proper subsets? Proper subsets are those subsets in which the number of elements are not equal. So for this we need to match two conditions. When each element of S1 is present in S3, and number of elements in S1 is not equal to number of elements in S3, then we can say S1 is a proper subset of S3. Now you can see the symbol for subset is this. However, the symbol for proper subset is this. It does not have an equal to sign at the bottom. That means the number of elements are not equal. Here we may have equal number of elements in both the sets. That's why we have an equal sign at the bottom. So for proper sets, we need to match two conditions. When each element in the first set is present in second set. That means this condition will tell whether S1 is a subset or not. And if we meet the condition of number of elements not equal, then it means S1 is a proper subset of S3. Now empty set. Empty set is simply a set containing nothing. It can also be written as this term in terminology. Now let's solve some questions from exercise 2a. So the question says, write using set notation 5 is an element of set D. So 5 is an element of set D. This is how we write it. 6 is not an element of set G. 6 is not an element of set G. D is not an element of the set of all English vowels. So D is not an element of a set. Which set? A set containing all the vowels A, E, I, O, U. Part D says 2, 5 is a subset of 1, 2, 3, 4, 5, 6. So what is the symbol for subset? This. So 2, 5 is a subset of 1, 2, 3, 4, 5, 6. And part E, 3, 8, 6 is not a subset of 1, 2, 3, 4, 5, 6. Let's move on to the next question. Decide whether each set is finite or infinite. Now a finite set is the set that has a definite value for the number of elements. However, an infinite set is the one that does not have a definite value for this term. So by solving a set of factors of 10. So what are the factors of 10? Factors of 10 are 1, 2, 5 and 10. Now if we find the number of terms, let's say this is set S, the number of terms in this set, there are only 4 terms, so we can write 4. That means that this set is a finite set. Multiples of 10, let's say S is equal to Now, what are the multiples of 10? Multiples of 10 are 0, 10, 20, 30, 40, and 50, and so on till infinity. And below 0, we also have minus negative 10, negative 20, and so on till negative infinity. Therefore, we can say here number of elements in this set is not definite. Hence, infinite set. Similarly, for part C, we have a set for perfect squares. So we know perfect squares start from 1, 4, 9, 16, 25, 36, and so on till infinity. Similarly, we can say number of elements in this set is not definite. Therefore, it is an infinite set. Let's move on to the next question. For each set A, list the number of elements of A and hence state n of A. So factors of 8. What are the factors of 8? 1, 2, 4, and 8. Therefore, if we call it a set S, then n of S is equal to 4. This is what the question is asking. Part B, composite numbers less than 20. So what are the composite numbers? Let's say the name of the set is C for composite numbers and its elements are 4, 6, 8, 9, 10, 12, 14, 15, 16, 18. That's it. So n of C is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the number of elements in this set is 10. Part C, letter in the word. So let's say the name of the set is S. So we have A. And one more thing about sets. If something repeats, we don't write it more than once. So for example, here A is coming 3 times. So we won't repeat A more than once. That will be A, R, D, V, K. So n of S is equal to 5. So this set, let's say it is M, is Jan, Feb, March, April, May, June, July, August, September, October, November, and December. So this is the set the question is talking about. So we know number of elements in this set is 12. This is our answer. Part E says prime numbers between 40 and 50. So let's say the set name is P for prime numbers between 40 and 50. So what are the prime numbers between 40 and 50? Is 41, 43, and 47. These are the prime numbers. So n of P is equal to 3. Let's move on to the next question. Let S is equal to 1, 2, 4, 5, 9, 12, and t is equal to 2, 5, 9. Find n of s. N of s is 1, 2, 3, 4, 5, 6. That is 6. N of t is 3. Part B. Decide whether the statement is true or false. 4 is an element of S. Now, can we see 4 in S? Yes, we can. Therefore, this statement is true. 4 is an element of T. 4 is an element of T. Now, can we see 4 in T? No, we cannot. That means this statement is false. 1 is not an element of T. 1 is not an element of T. Correct, that's correct. 1 is not an element of T. So, this statement is true. Part 4 says T is a subset of S. So what is the definition for a subset? When we say T is a subset of S, that means each element of T is present in S. So is it true? Each element of T is also present in S. 2, it is present. 5, it is present. 9, it is present. Then we can say this statement is true. T is a proper subset of S. Now what do we mean by this statement? This statement means that each element of T is present in S. Also, number of elements in T is not equal to number of elements in S, which is also true. It means we can say T is a proper subset of S. That means this statement is true. Let's move on to the next question. Let S be equal to 1, 2, T be equal to 1, 2, 3. Now part A says list all the subsets of S and T. So the subsets of S and T will be, when we have S 1, 2, all subsets will be, first there will be an empty subset, because empty set is a subset of every other set. That means this or this, the, both of them mean the same thing. So either this or this is a subset, then 1 is a subset, 2 is a subset, and 1, 2 is a subset. So this is for S. What about T? For T, we have 1, 2, 3. So all subsets will be empty set 1, 2, 3, 1, 2, 1, 3, 2, 3, and 1, 2, 3. These will be the subsets of T. Now part B says, is every subset of S a subset of T? So is every subset of S a subset of T? This subset is a subset of T. Yes, this subset is a subset of T. Yes, this subset is a subset of T. Yes, this subset is a subset of T. Yes. So we can say yes, every subset of S is a subset of T. Now, part C says, what fraction of the subsets of T are also subsets of S? So we can say this is a subset of this is also present in this. So take 1 is present, so this is a subset. 2 is present, so this is a subset. 3 is not present, so 3 is not a subset. 1 comma 2 is a subset. 1 comma 3 is not a subset. 2 comma 3 is not a subset. And 1, 2 and 3 is not a subset. So this is not, this is not, this is not, this is not. So we have what fraction of subsets of T are also subsets of S? So this is the number of subsets which are the subsets of S. That means 4, and total number of subsets is 8. That will be half, and that is our answer. Let's move on to the next question. State the number of subsets of P, Q, R, S. Explain your answer. So while solving these kinds of questions, what we can ask ourselves, there are 4 elements and each element can either be present or it can not be present. So what is the possibility of P being present in a subset? Possibility of P being present, there are 2 possibilities. Either it can be present or it cannot be present. So there are 2 possibilities for P. Similarly, 2 possibilities for Q, and so on. And hence there will be 16 possible subsets that will or will not contain P, Q, R and S. Therefore, this is our answer. Let's move on to the next question. Suppose A is equal to prime numbers between 30 and 40. B is equal to even numbers between 30 and 40. C is composite numbers between 30 and 40. And D is multiples of 21 between 30 and 40. So let's first form the sets. So set A is prime numbers between 30 and 40. So what will be the prime numbers? That will be 31 and 37. 35 is not 37. Yeah, that's it. Subset B is even numbers between 30 and 40. That will be 32, 34, 36, 38. Subset C is composite numbers between 30 and 40. So what will be the composite numbers? The numbers that are not prime. So what are those numbers? That will be 32, 33, 34, 35, 36, 37 is a prime number, 38, 39. So these are the numbers that are composite. And D is multiples of 21 between 30 and 40. So we know there are no multiples of 21 between 30 and 40. Therefore, this set will be empty, or we can write it like this. Now let's move on to question part A. List the elements of each set. So we have done it. We have already done this part. Now let's move on to the next sub part, that is B. Find number of elements in A. Number of elements in A is 2 and number of elements in D is 0. Part 1. Which of the sets listed are subsets of A? So subsets of A. So we have to check which of all of these sets are subsets of A. So let's take D. D is an empty set. D will be the subset of all of the sets. Therefore, we can say D and A are definitely the subsets of A. However, B and C contain the elements which are not present in A. Therefore, B and D are not subsets of A. Only A and D are the subsets of A. Now part 2, proper subsets of C. Now we know 31 is not present in C. Therefore, A is not a subset of C. For B, we see each element of B is present, each element of B is present in C. Therefore, B is, or we can say B is a subset of C. Also, number of elements in B is not equal to number of elements in C. Therefore, B is a proper subset of C. So we have computed about A and B. Now about C. C is a subset of itself. About D, D is also subset. Let's move on to the next question. Next part, true or false. Let's do it here. D, part 1. 33 is an element of C. 33 is an element of C. That is true. 37 is not an element of A. 37 is an element of A. That means it is false. 35 is an element of B. 35 is not an element of B. That means it is false. Hence, let's move on to the next question. Consider two sets A and B such that A is a subset of B. Find the possible values of x if A is equal to 2, 4, 6 and x, and B is equal to 2, 3, 5, 6 and x plus 1. Now we know A is a subset of B. That means each element of A must be present in B. Now from here we see 2 is present here, 4 is not present, so we mark 4 is not present, 6 is present here, x is not present, so x is also not present. Now what are the terms that differ from A in B? So the terms in B that differ from A are 2 we have 3, 5 and x plus 1. So we know a plus b. So we know a is a subset of b. That means 4 has to be present in b, and also x has to be present in b. So 4 is not among these elements. Therefore, x plus 1 must be equal to 4. That means x is equal to 4 minus 1, or x is equal to 3. So a will be 2, 4, 6 and 3, and b will be 2, 3, 5, 6 and x plus 1, that is 4. Now we can see a each element of a is present in b. 2, 4, 3, 6. 2, 4, 3, 6. Therefore, the value of x is 3. That is our answer. That's it for this exercise. I'll see you in next session.